How many 3-digit even number can be formed with digit 1, 2, 3? We already know how to form a number. With digit 1, 2, 3, we can form 6 numbers. They are 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. Within this number, 1, 3, 2 and 3, 2, 1, these two are even. With digit 1, 2, and 3, we can form 6 numbers where two numbers are even. Look carefully. Both the number are end with the digit 2. Both the case 2 is fixed but previous two digits are arranged. How can we find this value using permutation formula? Step 1. Fix one digit. In this case, last digit. And step 2. Arrange the other digits. By following these two steps, we can solve this type of problems. So let's solve one problem. How many 3-digit even numbers can be formed with digit 1, 2 and 3? So according to step 1, we have to fix one digit. That is the last digit. Here we have to form a even number. That's why we have to fix the digit 2 at the last position. Now we have two digits, 1 and 3. And we have two positions, this position and this one. We have to arrange two digits in two positions to find the number of permutation. Now, according to step 2, arrange these two numbers in these two positions, which is 2 factorial according to the rules of n factorial, since all the digits are different here. So, the value of arrangement is 2. Here, we just find the value using the permutation formula. So, the formula is when we fix any position by any object, we exclude that position and that object from the permutation. Let's see one example. How many 4 digits odd number can be formed with digit 2, 3, 6, 8? We have to form odd numbers. The solution is we have to form those numbers which are end with 3. Because here only 3 is the odd digit. We have to fix 3 as the last digit. According to the formula, 3 is excluded from the permutation. So the result will be 4 minus 1 factorial. Since all the digits are different here and we exclude one digit 3 from the 4 digit, that's why the result will be 4 minus 1 factorial. Finally, the result is 3 factorial, which is equal to 6. How many ways can the letter of the word identity be arranged so that all the arrangements start and end with the letter I? Let's see the solution. Our given word is identity. We have to find the arrangement which are start and end with I. First, we have to fix the first and the last position with the letter I. Then count the other letters. Here the counting is 6. Within that 6 letter, there are 2 T. So the result is 6 factorial divided by 2 factorial. Since all the letters are not different here, that's why according to the formula, the arrangement of all letters, that is 6 factorial, and divided by this 2 factorial is for 2T. And finally the result, which is 360. Special case. How many 3-digit odd number can be formed with the digit 0, 1 and 2? We have to form the odd number. The solution, we have to form those numbers which are end with 1, because within 0, 1 and 2, this 1 is the odd digit. So all the odd number must be end with this odd digit 1. We have to fix 1 as the last digit. According to the formula, 1 is excluded from the permutation. So the permutation will be 3 minus 1 factorial, since all the digits are different here. But if the number is start with 0, that number is not 3-digit number. Starting with 0 and end with 1. That case, the permutation is 3 minus 2 factorial, which is 1, because the first position is fixed with 0 and the last position is fixed with 1. So the remaining position is 1. That's why the value of permutation is 1. So the result is 2 minus 1, which is 1. Here the 2 is the number of permutation which are end with 1, and this 1 is the number of permutation which are end with 1 but starting with 0, which are not 3-digit number. That's why our result is 1.